every type of space habitat and colony concept. Space is complicated. We make it simple. Living in space isn't the hard part. Staying alive there for decades, raising children there, and never once being able to walk outside without a suit, that's the hard part. Every serious proposal for a permanent human settlement beyond Earth has to solve the exact same list of problems: radiation, gravity, air, water, food, and psychology, all at once, all without a single resupply mission being guaranteed to arrive on time. We're going in order from the nearest, most immediately buildable option to the most distant, most theoretical one, then we'll sort them a second way, by which single problem each concept solves best, because no proposal on this list solves all of them equally well. Lunar surface habitats. We begin with the nearest real estate, roughly 3 days away by current spacecraft, and also one of the most hostile environments on this entire list. The moon has no atmosphere at all, meaning surface temperatures swing from over 100 degrees Celsius in direct sunlight to below minus 150 degrees Celsius in shadow, sometimes within the same crater. And lunar days last about 2 Earth weeks, followed by 2 full weeks of uninterrupted darkness. Here's the fact that changes everything about where these habitats would actually be built. Current serious proposals concentrate almost entirely on the lunar south pole, specifically because certain crater rims there receive near constant sunlight for solar power, while permanently shadowed crater floors nearby are believed to contain significant deposits of water ice, preserved for billions of years in temperatures cold enough that it has never sublimated away. Here's the part that should genuinely bother you. The lunar regolith covering the entire surface is made of sharp, jagged, glass-like particles created by billions of years of micrometeorite bombardment with no atmosphere to smooth them down, and it clings to everything electrostatically. Apollo astronauts reported it wearing through multiple layers of spacesuit material within days and triggering respiratory irritation once tracked inside the lunar module, meaning any long-term habitat has to solve a dust contamination problem that Earth-based construction has never had to seriously consider. Underground and lava tube habitats. Here's the twist. The safest place to live on the moon or Mars might not be on the surface at all. It might be underneath it. Both worlds are known to contain lava tubes, long tunnels formed by ancient volcanic activity when the outer crust of a lava flow cooled and hardened while molten rock continued flowing beneath it, leaving a hollow channel behind once the flow stopped. Some lunar lava tubes detected by orbital radar are estimated to be large enough to fit an entire city block inside, with a ceiling of solid rock, potentially tens of meters thick, overhead. Here's the fact that should genuinely bother you about why this matters so much. That overhead rock does something no engineered habitat on the surface could match for the same cost. It provides near total passive shielding from cosmic radiation, solar flares, and micrometeorite impacts, along with dramatically more stable internal temperatures than anywhere exposed to the surface's extreme day-night swings. Here's the part that lingers. Building inside a lava tube means humanity's first permanent off-world city might not look like the gleaming domed settlements of popular imagination at all. It might be something closer to a vast retrofitted cave, chosen not for its appearance, but because the rock above your head is doing more life-saving work for free than any material we could realistically ship from Earth. Martian surface colonies. Here's the reframe. Mars offers something the moon simply can't: a thin atmosphere, a 24-and-a-half-hour day almost identical to Earth's, and confirmed reserves of water ice at both poles and buried at various latitudes across the planet. But that thin atmosphere is deceptive. At less than 1% of Earth's surface pressure, it offers essentially no protection from radiation and can't be breathed under any circumstances, while still being thick enough to occasionally generate planet-wide dust storms that can block enough sunlight to threaten solar-powered equipment for weeks at a time. Here's the fact that should genuinely bother you. Mars lost its global magnetic field roughly 4 billion years ago, and without it, solar wind has been slowly stripping away the planet's atmosphere ever since, meaning any habitat built on the Martian surface faces meaningfully higher long-term radiation exposure than a comparable habitat on Earth, even accounting for the thin atmosphere it does have. Serious proposals generally favor building habitats partially buried under a meter or more of Martian regolith, specifically to compensate using the dirt itself as makeshift radiation shielding, the same basic principle as a lava tube, just engineered rather than found. Here's the part that lingers. Unlike the moon, Mars is far enough away that a resupply mission from Earth only has a viable launch window roughly once every 26 months, when the two planets' orbits align efficiently, meaning any colony there has to be self sufficient enough to survive over a year between realistic opportunities for additional supplies to arrive, not weeks. Rotating space stations for artificial gravity. Here's the pivot. Every habitat described so far sits on a planetary surface, dealing with that world's specific gravity, atmosphere, and geology. This category abandons planetary surfaces entirely and tries to solve a different problem first. The fact that long term exposure to zero gravity causes serious, well documented harm to the human body, including bone density loss, muscle atrophy, and vision changes from fluid shifts toward the head, none of which fully reverse even after returning to Earth. The proposed solution, first seriously outlined by physicist Gerard O'Neill in the 1970s, is a large rotating structure, a cylinder, torus, or ring, spun fast enough that centrifugal force pressing outward on its inner surface simulates the sensation of gravity for anyone living inside, without needing to be anchored to a planet at all. Here's the fact that should genuinely bother you: the rotation rate required is a delicate balancing act. Spin too slowly, and the simulated gravity is too weak to prevent bone and muscle loss. Spin too fast, and the difference in centrifugal force between someone's head and feet becomes noticeably disorienting, potentially causing chronic motion sickness for anyone living there long term. Larger structures solve this more gracefully, spinning more slowly while still generating full simulated gravity, which is precisely why serious O'Neill cylinder proposals describe structures kilometers long, not for extra living space alone, but because bigger genuinely means more comfortable at the physics level for this specific design. The O'Neill cylinder and large scale space colonies. Here's the fact that reframes the entire ambition of this category. Some large scale rotating habitat proposals aren't modest research outposts at all. They're designed to house tens of thousands to millions of permanent residents, complete with an internal landscape of farmland, forests, rivers, and weather projected onto or built directly into the interior surface of a massive rotating structure, with sunlight either admitted through mirrors and windows or simulated entirely artificially. Here's the fact that should genuinely bother you about the scale involved. Building a structure large enough to comfortably house a self sustaining population at Earth normal simulated gravity would require assembling millions of tons of material in orbit, an amount of construction mass that current launch capability couldn't realistically deliver from Earth's surface in anything resembling a practical time frame. Meaning, serious versions of this concept generally assume the raw material would need to be mined directly from the moon or from asteroids, launched using far less energy than escaping Earth's own deeper gravity well requires. Here's the part that lingers. Unlike every planetary surface habitat on this list, residents of a completed O'Neill cylinder would never actually see a horizon in the traditional sense. The ground curves upward on every side until it meets itself overhead, meaning you could, in principle, look straight up and see your own neighborhood upside down, kilometers above your head. Hollowed asteroid habitats. Here's the fact that solves a problem none of the previous concepts fully address. Where does all the shielding material and structural mass for a large habitat actually come from, if not from Earth? Some proposals suggest skipping planetary construction entirely and instead hollowing out a sufficiently large asteroid, using its own rock and metal as the habitat structure and radiation shield simultaneously, then spinning the entire hollowed out body to generate artificial gravity along its interior surface, combining the shielding benefit of a lava tube with the rotating design of an O'Neill cylinder, using raw material that never has to be launched out of a gravity well at all. Here's the fact that should genuinely bother you about the engineering involved. Many asteroids are not solid rock at all, but loosely bound rubble pile structures, held together by weak mutual gravity rather than structural cohesion, meaning the specific asteroid chosen would need to be carefully assessed for structural integrity before anyone attempted to hollow it out and spin it, since a rubble pile asteroid could plausibly begin shedding material or destabilizing entirely under sustained rotational stress. Here's the part that lingers. Metal rich asteroids, believed to be the exposed metallic cores of long shuttered ancient protoplanets, could theoretically supply enough iron, nickel, and rare industrial metals to build multiple large habitats without ever needing a single additional shipment from Earth or the Moon, meaning the actual limiting resource for large scale space settlement might not be technology at all, but simply finding, reaching, and successfully processing the right kind of rock. Floating colonies in a planet's atmosphere. Here's the twist that most people never consider. Not every proposed colony needs solid ground at all. Venus, despite a crushing, lethal surface environment hot enough to melt lead, has an atmospheric layer roughly 50 kilometers up, where pressure, temperature, and even gravity are remarkably close to Earth's, and the atmosphere there is thick enough that a habitat filled with ordinary breathable air would actually float, the same basic principle that lets a helium balloon rise through Earth's air, just reversed. Proposals for floating Venusian cloud cities envision enormous balloon like habitats drifting permanently in this temperate layer, never touching the hostile surface at all, powered by abundant sunlight and shielded somewhat by the thick atmosphere above from certain types of radiation. Here's the fact that should genuinely bother you. Venus's clouds are composed largely of concentrated sulfuric acid, meaning any exterior hull material would need to resist corrosion that anything required on the moon or Mars. And the atmosphere's overall composition, while my the while breathable pressure compatible at that altitude, is otherwise completely toxic and would require full life support at all times, regardless of the pleasant pressure and temperature. Here's the part that lingers of every world in the solar system. The single most Earth like environment for unprotected human survival, in terms of pressure and temperature alone, isn't found on any solid surface at all. It's floating 50 kilometers above the most hostile planet in the entire solar system. Generation ship and deep space nomadic habitats. Here's the fact that closes this list on its most self contained note. Not every habitat concept needs to orbit or land on anything at all. Some proposals imagine fully self sufficient mobile habitats, essentially smaller, slower versions of the O'Neill cylinder, designed to operate indefinitely in deep space or interstellar transit, generating their own artificial gravity through rotation, growing their own food in enclosed agricultural sections, and recycling every drop of water and every breath of air in a completely closed biological loop with zero external resupply expected ever. Here's the fact that should genuinely bother you. Earth's own attempts to build and test a fully closed biological life support system on the ground, most notably the Biosphere 2 project in the early 1990s, ran into serious, difficult to predict problems, including unexpectedly declining oxygen levels that eventually required an emergency injection of outside air to keep the enclosed crew safe. A sobering reminder that a small, sealed ecosystem is a genuinely difficult engineering problem, even with the entire resources of Earth sitting right outside the walls for backup. Here's the part that lingers. Any habitat on this list intended for genuine deep space independence has to solve that exact closed loop problem completely, with zero margin for the kind of emergency outside intervention Biosphere 2 ultimately needed, for a mission that, depending on the destination, might not see a resupply option again for generations. Let's sort these 8 again, a different way, not by distance from Earth, but by which single problem each concept solves best. On the radiation shielding end, lava tube habitats, offering the best passive protection of anything on this list, entirely for free, simply by building underneath solid rock instead of exposed to open sky. On the gravity solving end, rotating space stations and O'Neill cylinders, the only concepts here that directly address the long term health consequences of zero gravity, rather than relying on a planet's own, often weaker, natural gravity. On the resource availability end, Mars offering the richest combination of confirmed water ice, a usable day-night cycle, and a thin but real atmosphere, compared to the moon's near total lack of protective atmosphere. On the psychologically comfortable end, large-scale O'Neill cylinders and Venusian cloud cities, both designed around the idea that humans living permanently off-world will need genuine sky, weather, and open space, not just a life support sealed bunker, to remain mentally healthy across generations. And on the fully self sufficient end, generation ship style closed habitats, the S only concept on this list explicitly designed to need absolutely nothing from the outside universe ever once launched. It's worth acknowledging before we close the one problem that appears in every single category on this list, without exception, and it's the one none of them fully solve through engineering alone: psychological isolation. Analog missions on Earth, including long duration simulated Mars habitats and extended Antarctic research postings, have repeatedly documented measurable declines in crew mood, motivation, and interpersonal cohesion over missions lasting many months in an enclosed, unchanging environment with a small, fixed group of people and no ability to simply leave. Here's the fact that should genuinely bother you: every habitat concept on this list, from a lunar lava tube to a kilometers long O'Neill cylinder, has to solve this same underlying problem. At a scale current mission planning has only tested for durations of a year or two at most. Nobody has real sustained data on how a small isolated community holds together psychologically across the kind of multi-year or multi-generational timelines several of these proposals actually require to be worthwhile in the first place. Here's the last thing we're sitting with. Every concept on this list is, in its own way, an attempt to rebuild the exact conditions Earth provides for free, breathable air, tolerable temperature, radiation shielding, and enough gravity to keep a human skeleton intact, using nothing but engineering in an environment actively hostile to every single one of those requirements simultaneously. We've spent our entire history as a species not having to think about any of this at all. The moment humanity moves permanently off this planet, all of it becomes the actual daily job. Not bad for stick figures on a rock.